Okay, so continuing on with our percent increase or decrease and discount questions, here's example 4, 5, and 6. And we'll start with example 4 is a wage increase, example 5 is enrollment decrease in the school, and you have to find the percentage, and example 6 is healthcare cost increase, and you got to find the percentage there, right? So we'll look at example 4, and a person earning $9.50 per hour is giving a 80-cent raise. An 80-cent raise. What is the percent increase? Round to the nearest tenth of a percent. So this time you're given the money increase, and you have to find what percentage is that. Okay? So let's walk through this. The thing we need to know is to get percent increase or decrease. This also works for decrease. Percent increase is the increase amount divided by the original amount. You always divide by the original. And when we do percent decrease on the next example, we're going to see that it's very similar. It's going to be percent decrease will be the decrease amount over the original, or decrease amount, you could say, right? Decrease amount over the original. So we have the increase amount, let's say, divided by the original amount. Okay. So we're just in this example for now. Now, what is the increase amount and what was the original amount? The increase amount is given straight up as 80 cents, 0.80. The original amount was $9.50. Okay? So we need to divide. Okay? So, of course, this is exactly the same as 0.8 over 9.5. And if you were doing, you would have to do 9.5 into 0.8, right? And you might remember the trick that you got to move the decimal point over here, and then you simultaneously move that decimal point over here. So that becomes 95 into 8 point, and then you would probably want to add on a bunch of zeros, right? Of course, that is moving these decimal points over here. Here's the same thing as taking this number, this fraction, and multiplying it by 10 over 10. 0.8 times 10 is 8, isn't it? 9.5 times 10 is 95. So we have 95 into 8. 95 into 8. Same thing, right? Anyway, just a reminder. So we've got to do the long division. Let's go through that together. 95 into 80 won't go. 95 into 800. Well, let's see. I'll think about my 9 times tables. 9 nines is 81. I'm going to guess 8 nines and see what happens. And if it doesn't work, I'll just try something else. 8 fives is 40. Carry the 4. 8 nines, 72. 4 is 76. Subtract. And I get 40. And bring a 0 down. Now 95 into 400. Well, let's think. 5 nines is 45. 4 nines is 36. So I'm going to try 4 and see what happens. 4 times 5 is 20. Carry the 2. 4 nines is 36 and 2, 38. Subtract. We get 20. Stick on another 0 there. Bring it down. 95 into 200. Let's see how far I need to go with this. The answer says, it says it wants the answer to be rounded to the nearest tenth of 8%. This is the percent amount. The decimal point has to be above here, doesn't it? So that means you're going to have a placeholder 0 here. So it's 0.084 or 0.084. Now we want to round to the nearest tenth of a percent. So I've already gone too far, haven't I? Because look, oh, hold on a second. No. No. Hold on a second. Hold on a second. Don't be silly. This is a decimal number, isn't it? This is a decimal number. So what I've got so far is 0.084. That's a decimal. Okay. Round that to the nearest. Turn that into a percentage. Okay. Turn that into a percentage. What does it become? How do you turn a decimal into a percent? Don't you go like this? Right? So we get 8.4%. Okay? But we want to round to the nearest tenth of a percent. So basically we should have kept going on this, because 95 into 200 would be about twice. 2 5s is 10, carry the 1, 2 9s is 18, and 1 is 19, subtract. Okay, so it should have a 2 on the end of it here, you see. And we want to round to the nearest tenth of a percent. We want to round to the 4 here, that's the tenth of a percent place. Even though it's in the thousands spot when it's a decimal, when it's turned into a percentage, this digit becomes the tenth of a percent place. So we get and of course we round down anyway, so it is approximately 8.4%, right? So the percent increase is approximately 8.4%, and that is the increase in the wage, $9.50 per hour to of course 950 0.8. Of course the new wage was $10.30 per hour. So from $9.50 to $10.30, the increased amount is 80 cents, and the percent increase is 8.4%, right? Okay, the enrollment in a school was in 2012 was 520. In 2013, the enrollment was 442. Find the percent decrease in enrollment from 2012 to 2013. Okay. So again, percent decrease is the decrease amount all over the original. Now, what is the original amount? Let's start with the bottom. 2012, 520 students. 2013, 442. Which of these would you consider to be the original amount? Well, this one, isn't it? Because that came first. So 520 is where we started at. And then the enrollment became 442. So what was the decrease amount? What is the decrease amount? The decrease amount is, of course, the original 520 subtract what it became. Okay? Isn't it? And so you've got to do this minus this, and let's see, carry a 1 or borrow a 1, borrow a 1. So 10 minus 2 is 8. 1 minus 4 won't work, so this becomes a 4. That becomes 11. 11 minus 4, 7. 4 minus 4, 0. So 78 goes up here. So the decrease amount is 78. The number of students decreased by 78, right? So the percent decrease is the decrease amount over the original. So we get 78 over 520. And we could do this, 520 into 78, and turn that into a decimal, and then turn the decimal into a percent. But it might be easier to try and put this in lowest terms first. Both of these numbers are even numbers. Okay? So 2 can go into the top and bottom, right? 2 into 7 goes 3 times, remainder 1. 2 into 18 goes 9 times. 2 into 5 goes twice, remainder 1. 2 into 12 goes 6 times. 2 into 0 goes 0 times. So we get 39 over 260, and of course you could do the long division, or you could keep trying to simplify this even further. And my advice at this point is factorize the top and bottom. Factorize the top and bottom. What I mean by that is, like, you look at 39. What do you think goes into 39? Can you think of any small number? 2 doesn't go into it, right? But does 3 go into 39? 3 times what gives 39? 3 times 1 would give the 3, and 3 times 3 would give the 9. So it's 3 times 13. Okay? Now on the bottom we have 260. Isn't that 10 times something? 10 times what? 10 times 26, right? Okay, so we have 3 times 13 over, and now 10 is what? 10 is 2 times 5, and 26. Can you factorize 26? 26 is an even number. 26 is 2 times what? 2 times what gives 26? Well, 2 times 1 would give the 2, and 2 times 3 would give the 6. So what this 39 over 260 becomes is 3 times 13 over 2 times 5 times 2 times 13. And we know we can cross cancel common factors, right? So what can we cross cancel here? What cross cancels? How about 13, right? Doesn't that cross cancel? So this whole thing becomes 3 times 1, 3, over 2 times 5 times 2. What's that? 2 times 5 is 10. 10 times 2, 20. Okay? So we have the percent decrease in fraction form, and I guess at this point we might, instead of 520 into 78, we just have to go 20 into 3, which is a lot easier, right? It's going to be a lot easier, right? But you want to turn your 3 to 3.000 and see what you get, right? So 20 into 30 goes one time. 1 times 20 is 20, and subtract, we get 10. Bring the 0 down. 20 into 100 goes how many times? 5 times, right? And 5 times 20 is 100. Oh, that went in evenly. That's nice. So we don't have to round anything. Remainder 0, right? The decimal point has to go above here, and of course you've got a 0 here. So the 3 over 20 becomes exactly 0.15. So the percent decrease, now we have it in decimal form. So this is fraction form. That's decimal form. Now we have to turn the decimal into a percentage. How do you turn a decimal into a percentage? Do you remember? You've got to move the decimal point 2 spaces to the right. So this becomes 15%. Okay? And the reason is because, look, 0.15 is 15 hundredths. 15 per 100. Or 15%. Right? So the percent decrease is 15%. The enrollment in the school was, in 2012, was 520. In 2013, the enrollment was 442. The decrease amount was 78. That was the decrease amount, was actually 78 students. The decrease percentage was 15%. Okay? Percent, I guess I could write here. Percent decrease. Oh, C there. Decrease. Okay. Let's have a look at healthcare costs. In 2002, the average cost of healthcare for a US family was $9,200, approximately. In 2011, after a steady increase of over $1,000 per year, the average family healthcare had risen to $19,400. What is the percent increase in healthcare costs from 2002 to 2011? So please press pause and try this yourself. We've already covered how to do it. So please press pause and try it yourself. So give it a few minutes and try it yourself. Okay, I'll go over it now. So percent increase is what we need. Okay. Now let's write this out again. Percent increase is the increase amount divided by the original amount. Okay. So what was the increase amount? Or what was the original amount? Let me ask you about the original first of all. What was the original amount? Which number? Is it 9,200 or 19,400? Well, wouldn't you say that this one is the original because that's where we started at? Okay. Now, what was the increase amount? Can you figure that one out? What's the increase amount? So don't you have to take this number and subtract this number? Does that make sense? So if I do that, I get 00201. The increase amount is $10,200. Okay, that's the increase amount. It increased in those 9 years. It increased by $10,200. The interesting thing is that there was no particular year where it jumped in price. It's a little bit over $1,000 every year. That's how it increased. Okay, so it didn't matter who the politicians were or what the events of the world were. Every year was just a little over 1,000 a year. Interesting. All right. Okay, so 10,200 over 9,200. So we have the percent increase in fraction form. What we need to do is turn this into a decimal and then turn the decimal into a percentage. So I would say the first thing we should do is simplify that fraction. I mean, if you want, you could try and do 9200 into 10,200, but that's going to be complicated, right? You'd be better off to try and simplify the fraction. So what's a quick way to simplify this? Well, if I divide the top and bottom by 10, the zeros would go away. And if I divide by 10 again, the zeros would go away, right? So I can write that as 102 over 92. Now they're both even numbers, so can't we simplify that further? 2 into 10 goes 5 times. 2 into 2 goes 1 time. 2 into 9 goes 4 times. Remainder 1. 2 to 12 goes 6 times. So we get 51 over 46. So that's a little bit of a nicer long division to do. We've got to do 46 into 51, right? So at least you don't have to do 9,200 into 10,200, right? And we probably want to put on a bunch of zeros here and do some long division, right? Okay. So 46 into 51 goes 1 time. 1 times 46 is 46. Subtract. And I get 5. Bring down a 0. 46 into 50 goes 1 time. And the decimal point goes here, doesn't it? 1 times 46 is 46. Subtract. I get 4. Bring a 0 down. Okay, interesting. 46 into 40. Goes how many times? 46 into 40? 0 times, right? 0 times 46 is 0. Subtract. And I get 40. And now I have to bring down this 0 and do 46 into 400. 46 into 400, let's see. 46 times 10 would be 460. So I'm going to guess 8, see what happens. 8 6s 48, carry the 4. 8 4s is 32 and 4 is 36, subtract. And this will end up being 70 32, right? And let's see how far we want to go with this. It didn't specify where to round. We're going to round to the nearest percent, the nearest whole number. Round to the nearest unit of a percent, or nearest whole percent number. Okay, so anyway, we've got approximately 1.108, and I just want you to round to this digit, because as a percentage, what is that as a percentage? Okay, we've got this in decimal form, but what's that in percent form? To turn a decimal into a percent, what do you do? Move this guy 2 spaces to the right, okay, and that becomes 110.8%, doesn't it? And I'm going to round it up because I want to round it to the nearest percent, and so it's going to round up, right? 111%. Okay. So basically, the percent increase in healthcare costs in the 9 years was 111%. So this is a practical application of having a percentage that's more than 100%. Let's put it this way: if the healthcare costs was $10,000, okay, and if that increased to $20,000, okay, then the increase over the original would be an increase of 10,000 over the original, which is 10,000, and that would be 1, okay, or 1.00, and as a percentage, that would be 100%. So what I'm saying is, if the healthcare costs, for example, increase from 10,000 to 20,000, that would be doubling. That would double, and that would be an increase, a percent increase of 100%. So if something increases by 100%, it means it doubles. Okay. So this more than doubled, right? Because we went from 9,200 to 19,400. Okay. Now, if 9,200 times 2, I mean, if we just double, that would be 0.0418. So if the healthcare costs in those 9 years doubled, we would be at 18,400. But we're even further. We're at 19,400 in 2011. So it more than doubled, and so the percent increase is actually more than 100%. So anyway, and then just for a little bit of education, you know, the percent increases come up a lot with prices of stuff. Like in 2002, price of a loaf of bread was $1.42. In 2011, that price of a loaf of bread average in the country was $2.10. That's a percent increase of 48%. Milk, a gallon of milk went from $1.98 to $3.50 on average in the country. That's an increase of 77%. A gallon of gas in the country went from $1.73 to $3.41. That's an increase of 97%. And we've just calculated the healthcare costs on average per family in the country went from this figure to this figure, which is an increase of 111%, which we just calculated. Okay, so some things increase more than others, and here we can see the healthcare did increase more than things like bread and milk. But the fact of the matter remains, everything increased in price. Everything: shoelaces, tables, chairs, you know, the price of water, everything increased. The price of electricity. So the question is, for our society today, like, why do things increase in price? You know, without fail. I mean, they never seem to go down in the long term, like every decade. I mean, they go up and down from day to day, but over decades, they always go up. Why? Many reasons why. But one thing that causes inflation that I think we all need to think about is printing money. If we just keep printing money and throwing it out there, the prices of things go up. So it's something to consider as a society, about this whole idea that we should just keep printing money over and over and over. Okay, anyway.